Good afternoon, dear colleagues. My name is Dina Huliieva. My colleagues Natalia Borysova, Zoia Kochuieva, Karina Melnyk, and I would like to present our research usage of sentiment analysis to tracking public opinion. The problem of public opinion analysis, especially its sentiment analysis, today actual and falls within the interests of many organizations, companies, and governments. Sentiment analysis can determine the emotional attitude of the author of the statement to any entity or to its properties, signs, parts, etc. It's not possible to do such analysis manually because of the following reasons. The first one, the public opinion can change quickly. The second, nowadays people can express their opinions via internet, so the number of statements which reflect the public opinion grows every day. Therefore, there is a real need to automate the process of a sentiment analysis of public opinion. So our research focuses on this purpose. So the object of our study is the process of tracking public opinion, and the subject is the theoretical and methodological tool for solving the task of sentiment analysis of public opinion. And the purpose of this work is to develop the sentiment analyzer of public opinion for Ukrainian language texts. To achieve the goal, it is necessary to solve the following tasks. The first, to conduct review of existing methods and software for sentiment analysis. The second, to choose a method of sentiment analysis. The third, to develop a model for formalizing the process of tracking public opinion. The fourth, to develop a model of the sentiment analyzer of public opinion. The fifth, to elaborate software requirements. And the sixth, to conduct numerical research. First, I would like to draw your attention to an overview of existing methods and tools of sentiment analysis. All methods of automated sentiment analysis can be divided into the following groups. The first, rule-based methods. The second, lexicon-based methods. The third, supervised machine learning methods. The fourth, unsupervised machine learning methods. Fifth, hybrid methods. All these methods have advantages and disadvantages, and I would like to know that in our study, it is proposed to conduct the sentiment analysis using the lexicon-based method. In addition, the analytical review of software for sentiment analysis was conducted. These software are based on different approaches for solving the problem and can be used in different conditions. The list of modern actively promoted software is presented on this slide. The analysis has shown that all considered software are multifunctional, but only 2 of them support the Ukrainian language. Other products allow downloading own model for sentiment analysis and or dictionary of sentiment words, but this service is paid or developers have set restrictions on the use of the models and the user dictionaries. Thus, the development of its own sentiment analyzer of public opinion for Ukrainian language texts is an urgent task. Let's consider the process of tracking public opinion based on using of sentiment analysis in more details. This slide presents the business process model in the form of BPMN-diagram. To start working with the sentiment analyzer, the user has to add a news item. Then administrator or other user has to add commands with defined category for this news. There are 3 categories of commands that correspond to 3 groups of people who are public speakers. The first, the opinions of the media, so the opinions of authors and articles in various online publications about particular news. The second, the opinion of the people, the opinions of ordinary citizens about news. The third, the opinion of expert, so the opinions of people who are the experts in domain related with given news. Next step is to tokenization and lemmatization for each command. This stage of analysis allows comparing the found words with the words available in the sentiment dictionary. If the word presents in the dictionary, its weight coefficient is taken for calculations. The tonality of each command further is calculated according to the model of determining the tonality of the news. Next step leads for calculation of the tonality of the comments with particular category. The purpose of the step is determination of the attitude of different public opinion leaders to each news item. Finally, classifier estimates the overall tonality for each news item. It means the general tonality of public opinion about the news. To assess the efficiency of the work of the sentiment analyzer, according to the standard metrics recall and precision, it is necessary to ask the tonality of all commands from experts of considered domain area. It was proposed in our research the using of the lexicon-based method of sentiment analysis. The main idea of this method is to use the tonal dictionaries where each word has a certain weight coefficient or several weight coefficients. The calculation of the overall tonality of the whole text is based on the weight coefficients of the words from the dictionary. The dictionary of words tonality has been made for developed sentiment analyzer. Calculations of the tonality of the text have been carried out according to the methodology by Jurek, Malvina, and Bayer that demonstrates the determining the tonality of the news for English language texts. This methodology was adopted, modified, and used for Ukrainian language texts. The process of estimation of tonality of news is shown on this slide in the form of the activity diagram using the activity element, defining the tone of the KISS command. The whole functionalities of the development sentiment analyzer for different categories of users are presented in the form of a use case diagram. There are three roles of user: administrator, user, and expert. The administrator can add and delete news, commands, comment categories, and user accounts, as well as view the tonality of the comments and news and the results evaluating the effectiveness of the sentiment analyzer. The user had the ability to add news and comments to them, view all the sentiment assessment results and the effectiveness assessment results. The expert has the ability to manually set own assessment of the sentiment of comments and view the results of assessing the effectiveness of the program. All data and results of the sentiment analyzer work are stored in the database. Let's consider the database model for the sentiment analyzer. Database model consists of following entities. The entity dictionary represents list of sentiment words with their weight coefficients. The entity news describes all news added by all users with their tonality expressed both in words and numerical value. The entity comment represents all commands for all news with their categories and tonality expressed both in words and numerical value. The entity category describes all commands categories. The entity evaluation range represents all tonality expressions by words. The associative entity command dictionary describes the set of words from the comment presented in a dictionary. And the associative entity news category describes tonality evaluation expressed by numerical value for each command's categories that belong all news. According to the aforementioned information, the standard metrics precision and recall have been used to evaluate the efficiency of the sentiment analyzer. According to the results of calculations, the following metric values have been obtained. Precision 0.861, recall is 0.849. Moreover, the value of the precision metric within the class has ranged from 0.807 to 0.921, and the recall metric from 0.775 to 0.930. Such results indicate that the sentiment analyzer works adequately in general and within each tonality class as well. The obtained values of matrix precision and recall of the lexicon-based classifier have been compared with the values of such matrix for two other classifiers, Naïve Bayesian classifier and RNN Cmeans classifier, based on recurrent neural network. Results for Naïve Bayesian classifier and RNN Cmeans classifier were taken from work where a similar problem was solved. All results of classifier's efficiency evaluation are presented in the table number 1. The authors of above-mentioned work describe an experiment where additional training of classifiers on slang corpus, which the tonality of slang words have been marked up, allowed to increase the efficiency of classifiers by 10–11%. Therefore, based on this information, we decided to supplement our dictionary with slang words and re-examine the work of the developed lexicon-based sentiment analyzer. The results of metric calculations for the same three classifiers are presented in the table number 2. Comparing the results of calculations of metrics from the table number 1 and number 2, the increasing of the efficiency of the work of the lexicon-based classifier hasn't happened by 10–11%. The increasing has occurred by 5–6%, and this can be explained by the fact that not every of the analyzed commands contains slang words. They are used only in the commands that the opinion of the people reflect. So, in this study, all the tasks were solved and the goal was achieved. Thank you for your attention.